All right, good morning, good morning. It's about 6:26 a.m. Thursday, June 22nd. It was a long night, but it went by fast, and I'm super stoked to be here. So today, my program is on simply supported beams, and I used statics principles to be able to calculate and display the shear force diagram and the bending moment diagram. So after doing some calculations and some pseudocode, I was ready to build my GUI. And it's been an awesome experience being able to use GUIs now to calculate such a diverse range of problems under different conditions. So anyways, here I have a picture of some point loads, a picture of a distributed load, a spot where I can change the length of the beam. I also can analyze simply supported beams for up to 5 point loads, and also under a uniformly distributed load if we so choose. So to start out, I want to show you an example from the statics textbook, problem 875. I'm a TA, so I have access to these solutions. So they have a simply supported beam with 3 newtons acting at 6 millimeters, 6 newtons acting at 6 millimeters, and a 1 newton distributed load. So if we come back to my program, to my GUI, I'm going to use meters instead of millimeters. Won't really change the shape of the graph. And so let's set the 3 newtons like they had at 6. And let's set the 6 newtons at 12 meters. So we'll also increase to a 1 newton distributed load, and we'll plot. Alright, so there's my shear diagram and my bending moment diagram. And when we come back and take a look at the solutions manual, scroll down, we see they have a shear diagram nearly identical to mine. I don't have the vertical lines, but it is the same. And a moment diagram that is the same as well. So really, really nice. So coming back, if I put my length of the beam at 20 meters, now let's put this force back down to 0. Let me show you what happens with, let's say, a force of about 10.7, that's fine. And we'll say 10 newtons down. So let's plot this. Alright, so I actually do have a slight angle in my shear force diagram because I left my uniformly distributed load on. I take that off, it goes back straight, and the moment is the shear is the derivative of the moment. And as you can see, it's positive and for the first half and negative for the second half on my shear diagram, going according to the slope of the bending moment diagram. Alright, so now let's take a look, I'll reset that, at another statics problem. So if we go back to the solutions manual, problem 71 has a great example of a simply supported beam. Here it is. It has 4 equal magnitude forces acting across a simply supported beam split into 5 segments. So let's replicate this on my simulator. So we come over here. We're going to make the length of the bar 15. Alright, and then let's make this, let's say 10 newtons each. So that's like the p-value that they had. And I won't use my last point load because that's a 5th point load. So they'll just be 0. Now let's go ahead and make these 3 meters apart. Oh, that needs to be 12.01. Has to be just a little bit big enough to be in the range for it to work. And let's go ahead and plot. Alright, shear force diagram, bending moment diagram, nice stair step, and a little tent shape. Let's go over to the answers. We have our nice stair step diagram, and we have our nice tent shape for the moment. So I am super happy. Like, honestly, it's been a really fun time being able to experiment with the GUI as well as the statics principles. It's really just been such a pleasure, this course, and I'm really thankful that I've been able to create something like this from my little knowledge of coding. And yeah, through these calculations and through applying the MATLAB principles, I've really been able to build this GUI to help with statics.